Okay, so this is another proof. This is another example of a proof. There are a few differences. This is the first time, if I look at a proof, that I am not trying to prove that a triangle is congruent to another triangle. So that kind of tells me I'm going to have to prove that, but that kind of tells me what I'm going to do here. This is also the very first proof that I'm filling out completely blank, right? There's nothing in there for me to match. The practice for you guys today does have like matching things to kind of help you through it, but this one doesn't. So I am going to first fill in the given information. So I'm going to go ahead and fill it in. As I fill it in, I am going to mark it on my picture if I can. I have AE bisects BD. So that one's done. Now, what does it mean to bisect? It means when it cuts it into two congruent pieces. So AE, this line here, and I'll highlight it so you can see it. AE bisects, and this is the more important one, so I'll make it brighter, I guess, orange, bisects BD. So the only one that is cut into two congruent pieces is the orange one. So if I wanted to write that, I would say that BC is congruent to CD. Now, whenever we have a word, what do I need to do? I need to define it. So I have this word bisect. So this is the definition of bisects. So I'm not done. I still have another piece of given information, and I'm going to erase my highlight marks and mark my picture. That's all that I've marked so far. I also know that AB is parallel to DE. And that's given. So I have all my given there. What does that tell me? Parallel lines tell me two things. Okay, I'm going to skip over to maybe another page, probably. Hold on, let's see if I can get it. Okay, parallel lines tells me two things normally. It tells me that my alternate interior angles are congruent, and those are my Z angles. And that's just like the little corner of my Z's. That's how I remember them. That's one thing it tells me. The other thing it tells me is my corresponding angles are congruent. So when I do corresponding angles, it generally looks more like this. If these are parallel, corresponding angles are sitting in the same spot at different tables. So those are my two options. So if I go back to my picture, am I going to be looking at my Z angles or am I going to be looking at my corresponding angles? And really what I'm asking is, did I take one of these triangles and slide it or translate it? Did I slide it or did I rotate it? I rotated it, so I'm going to be dealing with the letter Z. You guys can see the letter Z in there. So I'm going to just draw one. I'll highlight it. Maybe in a nice purple this time. That's a backward Z. Can you see which angles I'm talking about? I'm talking about angle B being congruent to angle D. Could I have picked angle A and E? Yeah, I could have. I didn't, but I could have. If you want me to go through the whole proof again when we get back and start with number 4 and do it a different way, I'll still get the right answer. There are two ways to do this. I just picked those. And why is that? You guys already told me that it's alternate interior angles are congruent. And that's why. So now that I know that, is there any other implied information going on there? What else do I know about these two triangles? They share an angle. They're glued together at an angle at a point, not a side. So it's kind of important to recognize that. I'm not going to have a reflexive property, but they are glued together at this angle. So I have vertical angles. Now, can I put angle C equals angle C? I can't because I have no idea which one's which angle, but I'm going to use 3 letters. Angle ECD, and guess what's in the middle there? C, which is my angle C kind of a thing, because that's where my vertex goes. ECD is congruent to ACB, and that's because vertical angles are congruent. So now, do I have enough information to show that these two things are congruent? In order to show two triangles are congruent, and this is kind of where I step back from the proof, I've marked my picture, are they marked the same? Are the two pictures marked the same? Yes. So I can cover up one of those pictures. Oh, I don't like using that because it always ends up messing up. And we will make it purple so that it blocks all the stuff that I drew. And if we cover up one of these triangles for right now, and I'm going to go ahead and label what's going on here. I'm going to put an S for a side, an A for an angle, and an X for something that's not marked. And it has to be marked. So we're starting with the vertical angle right here. What am I going to put? A for angle. What am I going to put right here? Here? How about with this arrow? X. Arrows do not tell me how long something is. The arrows are what gave me angles, so that's why I can't use the arrows. How about right here? And then I think I'm good. How are these two triangles congruent? I walk around the symbol, and I can only walk around the triangle this way, so I get ASA. Now I'm going to move my box. I need to make up my GPS statement over here, that thing that tells me what's congruent to what. I'm going to move my box, or I trashed it actually, and I'm going to write it down. I'm going to start with the top one, maybe, if I don't move the whole thing. I'm going to make my triangle look a little better. Triangle ABC. Now, order matters, so this is how I do it. I'm going to pick a different color, and I put a number 1 by the letter A, a number 2 by the letter B, and a number 3 by the letter C. In this triangle, I do the same thing. The number 1 is by the angle that's not marked. So which angle is not marked down here? E. The number 2 is by the one that's marked, but it's not the vertical angle. So number 2 goes down here, D, and finally, what's left? C. So that's how I come up with that being exactly right. It's that whole 1, 2, 3, 1, 2, 3 matching game. Now, here's the only difference from last class. If there is any statement, anything that comes after triangle equals triangle, if I'm proving anything else, I'm going to write it in. AC congruent to EC. That's something else, so that goes to CPCTC. And what the heck does that stand for? Corresponding parts of congruent triangles are congruent. CPCTC. So if anything comes after triangle equals triangle, it will always be CPCTC. So there's all the steps.